right. Good morning. Let's see if this. Let's test this really quick. Make sure the audio levels are still good. Yeah, good. All right. Good morning. Time flies. It's Sunday again. At least I hope it is. Yep. Let's just dive into the code. We got something new today. Like I talked about in the stream on Friday, I got a new webcam for streams that I'm not streaming in the morning. And then that meant that I could take my old webcam and put it up there so you can see my keyboard, because that seems to be something that people like. We'll see about this being in the way. I was thinking before the stream that it would be cool if my mat here could be chroma keyed. I'd have to get a new one, or I'd have to probably not dye this one, but I wonder if there's like a pad like this that I could get that was like green or something. I could get the camera to be a little bit more centered on it. And then this would be just hands and keyboard and mouse just hanging out in space. Might be kind of cool. Anyway, what are we doing today? Well, excuse my arm. I gotta adjust something. There we go. We are going to work on glowing Telegram, of course, as has been tradition for the last 7-8 months. But hey, it's coming along. We got, I think, the same top things that were on the to-do list from before. I have been doing some research, some looking into things. What's the idea for this project? Also, hey, Zepertist. I think it's probably that's how you would pronounce that, Zepertist. Welcome in. Hello. The idea for the project. So, the tagline: a tool for managing stream recordings. Yeah. So that the inspiration for this is what I started doing when I started streaming. There is a way in Twitch where you can send your VODs to YouTube directly. But it had some problems. So the quality of the videos is not that great. There was a thing where I did like a 12-hour live stream early on. Like I've been streaming for like a little over a year now. I started streaming last year around in March, and Memorial Day last year I did like a 12-hour live stream, and I could not get the video to transfer over to YouTube using that tool in Twitch. And so I decided I was going to start recording the stream video also locally on my computer and uploading it myself, and that will give me opportunities to like maybe trim off the beginning and the end, maybe split up the video into like sections, because I take a regular breaks through the stream, so I can like chop up the VOD into videos. And so I was doing that with DaVinci Resolve and just like doing everything by hand. And I guess I had done that for a few months at that point. So towards the end of last year, I was like, hey, I should like build a tool to like help me automate this and look to see if I can use like ChatGPT or AI stuff in general to like generate video descriptions for the VODs, maybe like find interesting things to like extract highlights or clips, or help me do more edited content potentially in the future. So that's kind of the list here. And what we have today is to track locally recorded clips from a stream. So I say clips here, but I mean just like the local video files. Like I have OBS set up to record 20, like the local recording is in 20-minute segments. So it makes a separate video file for, hey, now I can use my hands to gesture and talk on these streams. Anyway, so that's what I mean by clips here. Generate a set of episodes from the stream based on when I'm speaking. So I do silence detection using FFmpeg to find basically where I'm taking my breaks because I'm not talking then. And, so I'm extracting that information. Episode transcription, so I'm using OpenAI Whisper to do speech to text transcription. And then I am, so that's done. So the review interface for transcription sort of exists, but needs to be better. That's on the list of things to do at some point. Automatic summaries for the episode via text summarization provided by GPT-4. That also exists now. Do I have the app open? I think I closed all of my tabs. Localhost :8088. So this is all just, it's a web UI with a Rust, it's a web UI using React and React Admin and TypeScript. And then the backend is Rust, running inside of Docker containers. And so like if we go into an episode, go to like episode 65 here, and so this has available to it the transcription that I did on the stream, which is over, let's see, let me remove this filter so we can see those. So like here is the record that represents the stream from the 21st, so last week. And then if I go over to transcript, here is the speech to text transcription that ran when I like loaded the data in. So this is all the things I said roughly. And then audio tab has like, here are the detected silence segments from the stream. And then the timeline is what I used before to like select, okay, what are the parts of the video between the silence segments? And then I can bulk create episodes. So it would create 3 episode records from the stream, right? So from this, then what I can do is I can click this chat button here. It's very kind of subdued, hidden right there, but click that. And what this does is it puts together basically what it's going to send to the OpenAI API, right? So like, here's the prompt. I summarize the provided video transcript into a title and description. It should be well-formed JSON response that looks like this. So here's the prompt, right? And then second section here is like, here is some information about the video. Like here is the tentative title. This is just basically from the stream title with the episode number tacked on. And then when the stream was recorded. And then I don't have a base description here. And then here's like me telling it, hey, this is the URL for my Twitch channel, right? So I can use that. And then this part here is just the transcript with timestamps. So I'm feeding this all, and like if I click the start button, this sends all of this data to OpenAI's API, right? And in a few seconds, we get a response as JSON. Unfortunately, the chapter stuff is not so great because the data that this has is based on the timestamps of the transcript from the raw stream. But between that and the actual video that gets uploaded, there are edits, right? There's stuff that's cut out, and potentially. So these aren't necessarily accurate, and it's kind of hit or miss anyway. But the description is very helpful, although I found that it started doing something different recently, where it speaks in the third person. Like, this is supposed to be my description, but it says join Saban. I mean, maybe it's just not really a style I like, so eventually I'm going to need to change the prompt, which currently the prompt is hard-coded into the component that I'm using here. But yeah, so that's kind of diving into one aspect of it, but that's the idea, and then I can just like click a button to say, hey, use this message, And if it parses correctly, I have a video description.
It's about tending to the broken parts.
And then the idea is then I can take this, and if I go back to the episodes list view,
Create things
I can click these and I can say, hey, upload to YouTube. Yeah, thanks. It's been, this is like 7 months of me mostly working on this 3 hours a week on Sundays. There have been some spots where I've had some time after work here and there, like, or, you know, on the weekends to put a little bit more work into it, but most of the work on this has happened on stream and is going to continue until I feel that it's not. What am I trying to say? Like I'm actually already getting something out of this tool because it's saving me a bunch of clicks in YouTube. It is saving me time finding all the media files and doing the very rough editing and adjustments and setup in DaVinci Resolve. Because what I can do is on these episodes is I can click this and I can click bulk export OTIO. OTIO is an open timeline format that DaVinci Resolve can import. DaVinci Resolve is a video editor, if you're not aware. And so I can take the exported files, import them into DaVinci Resolve, and it has like all the paths to where the actual video files are. So it like creates the timelines, it imports the files, it orders them in the right order, it trims them in their appropriate way to like start where the episode is supposed to start and end, and it adds transitions, like an intro transition, and it adds my outro video, and to the end it has the little placeholder things in the video where like the click here for a recommended video, click here for next video on playlist, that stuff goes. So that saves me a bunch of work already. It's not perfect. Like the description stuff could be better. There's still stuff I want to do with it being able to generate highlights and help me do more edited content. The workflow is not great. It's all very like ad hoc, like, oh, I have to go here and then I have to, you know, create a thing, or I can import the stream from Twitch to create a stream. There's a bunch of stuff that I want to do to make this better and to save me time. And a lot of that's in this to-do list. So yeah, that's kind of the summary of the project. So yeah, thanks for asking. What I really should do is I should take like that segment of this of what I just said and make a separate video and just have a like that as a video. Maybe I'll do that. That explanation is too long to be short. Maybe I could edit it down. Anyway, so today though, we're just gonna, I say we, I'm gonna just start working through the list of things, I think. So this one, use chain tasks to add videos after to playlist after upload to YouTube. So, right. So last stream I was working on this chained tasks idea, and kind of implementing that. And the idea here is that we have this task worker. We have kind of like a Redis queue kind of system here, where a priority queue, in fact, using a sorted set, if I remember right. And so the idea is that when the worker completes oh, this is lib. That's not where I want to be. When the worker completes the work of the task, is this? Yeah, oh, here we go. Okay. When it completes the work, if there is a next task, then it creates a task using this task template. And essentially allows us to chain tasks one after the other. So that we can do things like, it's basically like workflow stuff, right? So we wanna have a process where we upload the video to YouTube, and once the video is uploaded and that task, that asynchronous background job is complete, then the next task is to add the video to a designated playlist. And so that the mechanism to do that should work, although I guess we've not really tested it. So today, to move this forward and actually make this do what I want to do, I need to change how we're uploading videos to YouTube. All right, so we have, there we go. Let me just fold everything. I do have a bunch of stuff here that I could improve upon, but I'm not going to let myself be distracted. So we're just going to fold all the things. Okay. So upload enter is the part that actually makes the attempt to upload the content. Oh, I'm brainless. Good morning. You got Fedora installed, huh? Nice. As you can see, keyboard. I might even use it today. We'll see. I'm not sure about the placement of it. This seemed like maybe not the worst place. I guess it could also go like up here, maybe. It might be a little bit too low on this one. I don't know. I don't know if we're covering anything important here. Okay. Well, we'll see. We'll see. Okay. So I don't think we need to change upload enter. Right. So upload enter is called by something else. Get upload status is our function to check on the status of an upload to YouTube. I don't think we need to change anything here. Upload is the function that wraps upload enter and then handles different failure conditions. Okay, so, well, it's not public, right? Something is calling it in this file. And there's add a video to playlist, which is the, it adds the video to a playlist. It's also kind of an internal thing. All right, so that's all kind of implementation stuff. But up here, upload start task handler is responsible for calling task start, which is this helper function that makes an HTTP request to the task API endpoint. And I think we changed task request to also take a next task. Good. So I think fundamentally what I need to do here is, okay, so I have this to task request function that, oh, here we go. To do, this should be a task template for the next task. Okay. Figure out how this should work. Something. Task request of a thing. Not this. What do I actually need to do here? So next task on this one should be none. The idea is going to be that we're going to... Oh, right. Okay. So we're going to need to have a new endpoint. Right? Because the task service, in order for it to do anything, it calls back to the API to do the thing. In this case, like currently, there's one thing to call, which is the thing to just upload the video. What we want to do is we want to have a second one, a second endpoint that's going to be responsible for okay, here we go. Here's upload video handler. So this is the one endpoint. This is the implementation of the one endpoint that the task service currently can call. And I want to create a new thing here. I think maybe, yeah, let's start kind of bottom up. We're gonna move this playlist stuff into it. Okay, so this is gonna be maybe add video to playlist handler. Not you add. I should learn where. Is there? Hold on. Key map. Do I have another place where I have an underscore on my mapping? Besides, all the way up here. It's kind of awkward. What about in symbols? Yeah, right there is an underscore. I mean, a lot of it. But the thing is like I know where an underscore is. It's right there, but it's awkward to get to. I have to like completely shift my hand over. So I was just thinking, is there a better place? And there is. It's down here. But it's those kind of less used keys, or keys that in practice I'm not overly worried about them kind of like moving me away. Okay, so we need a different payload here. So we want like a YouTube playlist add task payload, something like that. Yeah, like that. Okay, so is this all I need? The playlist ID, and then the video ID, and the position. Except I'm not gonna have the video ID, because the video ID we're gonna get in the data from the task that completes to invoke this task. So it's going to be like this. So I'm going to mirror that value. That should be sufficient. Okay. So then what I want to do is I want to take the playlist portion, so this stuff, I want to move it down to here. And we'll update this. Oh, why does add video to playlist take the... interesting. Probably want to change that. What's... Oh, I see. It seems like an incomplete refactoring. Let's see. Okay, so what I'm gonna do is change this to take this as an argument. Something like that. course, I decided this was going to be a U32, so this has to be some body.playlist position, something like that. Of course, we don't have a video ID yet. Figure out where that's coming from. This is unhappy. Need to give a successful HTTP response if we get to the bottom. That's most of it. It's not all of it though. So how the task worker works is that we use in create task. When we create the task, payload is back. Where are we adding the previous data to the payload? Not here either. Huh. Didn't I? Oh, maybe it's inside of queue task. Or wait. Maybe. Oh yeah, build task payload. Okay, so we do the thing where we get the previous task in the chain, get its result from Redis. When we get to the point where we're actually invoking the next task, just to kind of, I guess, to minimize the amount of like times we're copying that. A different thing I could have done is actually have the thing that we invoke pull the data back out of Redis. But if I were to do that, then that would mean my YouTube API stuff, all the things that the task invokes, would have to know how to talk to Redis and find that, or there would no longer be this API layer separation. It would break that abstraction. To figure out something else to make sense of it. So here's a question. We have this at previous task data. So I think the idea is going to be that the struct here should have a key called at previous task data, which is going to be a value. That just like other places we're referring to asserted JSON value, so I'll use that. Control C, there we go. Now, I'm not surprised I can't do this. What there's probably a asserted only one? Okay. A way to alias this, right? I guess I'll go look at Rust docs. This might be gonna be close. Implementing a serializer. value, struct flattening, generic type bounds, deserialize for custom map type, array values, stop buffering. Serialize fields as camel case. Rename all at the struct level. It's interesting. How do I... Hey, Moody Abigail. Thanks for the lurk. we got 2 bots acknowledging the lurk this time. Attributes. Field attributes? Oh, rename. This is also a container attribute. This is a variant attribute. What does it mean? Okay, enum. Field attributes. Rename. Or alias. Deserialize this field from a given name or from its Rust name. Okay, so we could say, oh, an alias. Right, so we would take... okay, well, let me look at rename first. Rename name. Serialize and deserialize this field with a given name instead of its Rust name. This is useful for serializing fields as camel case or serializing fields with name in a reserve. Rust keywords. I think this is what I want. Rename. Rename. Definitely not. At previous task data. There we go. Okay. So that should be good. Oh. Now, what's in previous task data? And do we want to create a struct representing that as well? Maybe. So build task data. What is it stuff in there? It's an array. It's an array of something. It's an array of things that are the individual records stored. So essentially it's a vector of the responses from the something. Let's get task data. Uses con L range from the data key. So it looks up where we're storing the data in Redis, and it's getting all of the values in that list. So where do we use generate task data key besides in tests? For some reason, we don't use it in the place where we're storing the data. Maybe it's being used in this file. Okay, so when we get a successful result from doing the task, we get the response. We get the data by looking at the data key. So this isn't the whole response. We don't capture the whole response from the YouTube upload endpoint. We pick out data key. So a question. Let me do this. Let me split. Can I just open this file again in another tab, or do I have to split? I guess I'll split, right? Okay. Because what I want to do, so we have this struct, but then we also have what am I thinking about? Oh, right. Where are we constructing the, here it is, the task request, right? And so we say the data key is summary, right? The data key is summary. So that means that in the response to upload video handler, we return summary and it's a vector. Does it need to be a vector? How is this supposed to work? So we get task data key, and we say r push to task data key data str. So we serialize whatever we find inside a summary. So this. I don't know why this would need to be a vector. I don't think it does need to be. I think what we could do is we could do something where we I think it should still be like a sort of JSON. How do I object? Can I do that? Value. Well, I could just do this. Yeah, let me just do this. And I just want the video ID in the summary, I think. Except I don't have, or... Oh, I see. So right now, I am only getting the video ID if there's a playlist to, oh, that's interesting. So here's a question. I don't have a way inside of the first task to say the second task doesn't need to be done. It's funny, I was thinking about this yesterday, kind of like how we're doing this tasking system and whether I wanted to use something a little bit more general purpose. You fixed Steam, nice. Yeah. Is it still like a proprietary, like you gotta use NVIDIA's driver? Like their closed source driver or whatever on Linux. It's been a long time since I've had to think about that. Yeah, that's sad. So right now I don't have a way of saying, hey, I don't actually need to spawn another task. Like I don't have a thing that I could potentially do if I wanted to change around how I'm doing things is be like, let tasks return a message saying, hey, go spawn this other task. That's not how I ended up designing this, right? The way this is set up right now, when you invoke the first task, you have to tell it about everything else to do. So that's like a choice. That could like carry on to be like, you define this like state machine and you send the state machine to be processed, and then you could have like conditional things in it. Like you could go down that path, or you could have each individual like task tell the tasking system what to do next. We're not really set up to do the latter. We are moving in a direction of doing the first thing though, but I don't know if I'm gonna really need that. I guess what I can do for right now is what? Oh, right. I know what I can do. This is really simple, right? So what I can do is I can say, if there is a playlist to add, like right in the YouTube upload request, right? Because this is implementing a thing for this struct that's defined somewhere up here. Right? So playlist ID is optional, right? So what I can say is if the oh yeah, okay, let's do this. So what I'm gonna do is I'm gonna say hey, payload dot playlist ID, yeah. So something like this, yeah. I don't know that I want to call it YouTube playlist add task. I could define a URL like that. I guess that's fine. Title, add video to playlist. We're not passing in this. Yeah, I think that's fine. And then in here, I guess I will make this optional. There we go. Okay. We have playlist ID and playlist position. I guess, you know, to really a thing I could do is I could be like, what is this? There we go, this thing. I could do that. Can I save this? Oh, it needs .2str. Or toString. One of the two. That one. Okay. Okay, so I don't know that we need the box here. That doesn't seem to be necessary. Let's see what Clippy thinks. Hates it. What now? Okay, so we have a expected enum option, task worker, task template, found enum, task request. Okay, that makes sense. There should be a task template. Oh, I don't have it imported. Interesting. Much better. I was playing Mind Over Magic on Debian, and video was not getting detected, and the lag was horrible. Oh yeah, I bet. If you can't take advantage of GPU stuff, things. Okay, doesn't like that. Oh, there we go. toString like that. Okay. And next task none, right? So we're saying that the way to take a YouTube upload request and turn it into a task is to first create this task that's going to do the upload. And then when that's done, it will then create a task to add the YouTube video to a playlist. And the payload is going to be initially be the playlist ID and the playlist position, and then the previous task data will be null initially until we get to, you know, the part where it actually invokes the task, and then we'll get the data from the first task that will have the video ID in it. And then we're going to expect in both cases that the responses to these endpoints will have an object that will have a summary key, although we're not doing anything with it in the second case. So this is the thing. Right now, it's upset with me about things. Oh, okay. Upload video task output is a struct that I defined, and I said it was going to be a summary, a vec of string. Okay. Just do assert JSON value. Or I could do something else. All right, and now we don't have the video ID. So what I'm going to do is we are not going to care about the playlist ID here. In fact, I'm going to take let's see. All right. YouTube upload task payload. It's the thing that we're then reading from to build the full. Okay. So I can't take like playlist ID and position out of this. If I had like separate enums, one for like the raw request coming in, and then another for what we're passing to the essentially the callbacks. And I could do that, but I didn't. Right, so this handler, upload video handler, is what's called by the task API. And upload start task handler is what's being called by the front end to create the task. And they just happen to share, they're using the same YouTube. Are they using the same? No. No, they aren't. I was cleverer than I thought I was. All right, good. Interestingly, this is something where, I don't know. I guess I could create like a struct that had all the common fields and then refer to it in both. And that would be the way to avoid duplication. I'm not going to change that right now. I do want to use these validate. Macros. I think that's what you call them. Anyway, these things on both. And then in the YouTube upload task payload, I don't need the playlist ID or playlist position. All right, and what's going to yell at me about? Cannot find attribute validate in the scope. What do you mean? I'm using it right here. Oh, right. I need to add validate to the derive here to make that work. Okay, cool. And then it's going to say, okay, well, we don't have a playlist ID or position. All right. Okay. So this is what this is doing, right? So this is how you convert a YouTube upload request into a YouTube upload task payload. Is this function. So we're just taking select fields. And then what else is broken? No field playlist ID on type. Handlers YouTube upload task payload. Right. Why are we doing this? It just like passes through everything, right? I don't think we need to do this. Why don't we just use self? Oh, right, because the payload needs to be the... Right, I see. So what we're going to do is we're going to do that here. So that gets the task payload from the YouTube upload request. We'll convert it to JSON and pass it to the payload for the first task. And then I didn't make a fancy from for this one. I could do that. I might do that someday. All right. So what's broken down here now? Okay, so now at this point in the upload video handler, we don't have a playlist ID anymore. There's nothing for us to do with this. What we're just gonna do is I'm gonna try to select a couple lines. There we go. And we're just gonna do this. So we're always gonna get the video ID because we don't know if we're gonna need it or not. Now the contract for this API is different. We're always gonna return the video ID. So we just need to figure out what that is. It's not like it's a big deal. We just have to parse the response from the API call we already made to get it. And then we can do some error handling. Like if we can't parse it, something went wrong, we can report on that. Okay, so that's upload video handler. We're removing work out of it to ship that work elsewhere. And then in YouTube playlist add task payload, this is not going to be assert a JSON value. This is going to be a now we're going to do something else. We're going to do a derive pub struct YouTube upload yeah, whatever. Response? No response. So that's the shape of the data that we're expecting it to get back out. So I can then just say previous task data is this, except it's not. Unfortunately, it's a vec. What? How do I do that? Oh yeah, vec of that. There we go. Because of the nature of the tasking system, the previous task data is potentially a list of things. Now we know in this case that there's only going to be one thing in it. So we'll have to deal with that. But this is the shape of the data that we're getting. So then we changed this to be optional anyway, so I don't need to wrap it in a sum. Video ID. Match body previous task data get 0, or we fail out. Okay, so maybe this works. Once Kleppy is finished analyzing. Reference. Okay. What did Copilot give us? Okay. Let's response. Response. Okay. There we go. Are you happy now? Takes a second. There we go. Okay, so one more error. Oh, right. Okay, so oh yeah, we can just do empty vector, right? That's how you do that. It's got to think again. There we go. Okay. Cool. So, hey, no more errors. And now we've kind of split the work into 2 separate tasks and one chains onto the other one. Maybe it even works. I guess we can test it after the break. I'm going to go get some water. Take a quick walk around the house, and I'll be back in just a couple minutes.